Assalamualaikum and very good day. So today we are going to continue our lesson in industrial engineering. We are still in chapter 2, which is on total quality management. So for this lesson we are going to discuss about 7 QC tools. So this is the learning objective for this lesson. Develop check sheet, histogram, cause and effect analysis, Pareto, scatter analysis, control chart, and also flow chart. So the content are 7 QC tools. So basically the 7 QC tools here are the commonly used tool in order to identify the problem and also analyze the main problem in our organization. So basically these are the tools that normally being used to screen the problem, and from there we try to propose a suitable solution. The first tool here is the check sheet, an organized method of recording data. So I believe that you're familiar with this type of tool. This tool using is used for the counting purpose. So for defect, for example here, for the first hour we have 3 defect, 2 defect, and so on. Then for this one is the telephone interruption. The reason wrong number, for example here on Monday there are 5 interruption, on Tuesday 2 interruption, Thursday another 5, on Friday is 7. Then from there we can total up the number of interruption or non-conformance. So this is a quite straightforward tools. The second tool is the scatter diagram. This one is also known as correlation chart. Graph shows a relationship between two measurements. So basically for scatter diagram we want to monitor the pattern of the parameter that we observe. So normally we will look at the dependence and independence variable. So this is the independent variable, absenteeism, and productivity is the dependent variable, and we want to look either there is a correlation between absenteeism and productivity. So in general, if we look at the scatter diagram, this one, we can say that the higher absenteeism here will affect to the lower productivity. So this is the scatter diagram. The third one is cause and effect diagram. This one, this chart is also known as Ishikawa, or fishbone diagram. A tool that identifies potential sources of process variation that may affect an outcome. So basically for cause and effect diagram we have 2 parts, the effect part and the causes part. Right. So for the effect, we can put any problems here. And then for the cause, at least we need to look at these 4M causes. Material, method, manpower, and machinery. So at least we need to look at this 4M. If we have additional causes, like in this example, we have an additional of environment, we can put that. So otherwise, if you are needed to construct a cause and effect diagram, I repeat, at least you need to have this 4M for the causes, and for each of the branch here you need to detail out. Next is a Pareto chart. A graph to identify and plot problem or defect in descending order of frequency, focus on major problem and vital few. Okay, so basically the Pareto chart is sorted in descending orders, and then from there we will calculate the cumulative percentage of the non-conformance. Okay, so then from there we will take where the 80% of the cumulative problem happen. Okay, this line so means that we need to focus on this problem, okay, to solve the overall problem. Okay, next is a flow chart. Okay, process diagram, a chart that describes the step in a process. Okay, so when we want to analyze or assess the process, we try to put the process in flow chart. Okay, like this one. Okay, this is the operation or the process of preparing the food. Okay, begin or start, then make the order, then they have an option here, want fries, if yes, order fries, no, they ask about the drink, okay, and until the payment, then end. So from here is basically we can identify the process, and then after that we can basically classify, is it each of the process here are the value added or non-value added activities. If the activities are non-value added, basically we try to minimize and also eliminate. Next is histogram. Okay, distribution showing the frequency of occurrence of variable between high and low range of data. So this one is basically indicated the frequency, okay, number of occurrence for each range that we set in our histogram. And finally, number 7 is statistical process control chart or SPC chart. Okay, for SPC chart is a popular chart being used in industry and also in research to what we call to monitor the process. Okay, for statistical process control chart with a time and the horizontal axis, okay, to plot value of statistic shows upper and lower limit of the process. Basically we will learn in this course how to construct the control chart later on. Okay, this is an example of cause and effect diagram. Okay, this example is for problem with airline customer service. Okay, dissatisfied airline customer. So this is the problem or effect. Okay, this is the problem, dissatisfied customer service. So at least, as I mentioned, we need to identify the causes for this problem using 4M method. So machinery, material, methods, and also manpower. And from there, okay, we will detail out the reason or the causes. For machinery, for example, you need to detail out, okay, we have a mechanical delay on plane, okay, broken luggage, carousel, then de-icing equipment not available. So this is the problem that related to the machinery that finally contributed to dissatisfied airline customer. So if you look at the manpower, so they have detailed out understand ticket counters, understaffed crew, poorly trained attendees. For the method, bumping policy, overbooking policies, and so on. Right, so basically in order to construct this diagram, okay, you need to do or you need to make the brainstorming session, okay, in your team. Right, so try to identify as much as causes possible that contributed to the effect that we want to investigate. Okay, the second example here is the Pareto analysis chart or Pareto chart. Okay, basically in Pareto, if you read about the Pareto concept, basically they will point out that the main focus is to their concept is to focus on 20% of problem and solve 80% of it. Sorry, focus on 20% of the cause or the reason, okay, and we can solve 80% of the total problem. Okay, so by using this concept, basically we just concentrate or focus to solve really main problem that contributed to high non-conformance or high failures. Okay, this is the flow chart example, packing and shipping process. Okay, for inspection, role of inspection here. Alright, so basically in this example we have the packing station, sealing, waiting, labeling, quick freeze storage, okay, storage and shipping dock. Okay, then inspection here. Okay, role of inspection involve examining item to see if an item is good or defect. Inspection involve measurement, testing, touching, weighing, testing of the product, detect the product defective product. Okay, then issue when to inspect and where to inspect in the process. Okay, so inspection is basically, we can say for time being, is a compulsory process in the production or manufacturing. Okay, this is to ensure that the product that has been manufactured fulfill the required standard. Okay, but the inspection here will come with cost. Okay, so when and where to inspect? At the supplier's plant while the supplier is producing. So if our company purchase material or sub assembly from the supplier, so we need to have an quality engineer or quality checker to be in the supplier plant. Okay, then at your facilities, open receipt of good from the supplier. Okay, so when the supplies arrive at our facility, again we need to inspect before costly or irreversible process. Okay, so before we conduct the process that will cost us a lot of money, right? So we need to check the product during the step-by-step production processes. Okay, during each processes also we need to make an inspection. Okay, normally the operators will be trained, okay, to inspect the goods that they receive. Means that if we have a few workstation, okay, A, B and C, okay, operator in station B will check the goods or the parts that being delivered by operators in station A. Okay, if the part is not in good condition, they can reject. Okay, when production or service is complete, okay, so again inspection need to be made. Then before delivery from your facility, before we deliver the product to the next customer, especially the external customer, then at the point of customer contact. Okay, so these are the place or the point where the inspection need to be made. Okay, but the problem for inspection here, the worker fatigue or the ability of the worker. Okay, so so basically they cannot inspect every single item of the produced product especially when it's involved a mass production in large quantities. Okay, then measurement error. Okay, sometimes they have a problem with the measurement reading. Okay, maybe because of the gauge that they use itself is not accurate, or maybe because the workers are fatigued, so they will come out with error in the measurement. And also process variability. Process variability means the variation that we have in the process. For example, if we have a stamping process, okay, stamping process, we have a die, okay, upper and lower die. Okay, the pressure, for example, should be 2.2 ton. Okay, so they have some plus minus here. Sometimes it might be 2.25, sometimes it might be 2.15, and so on. So this variation will also affect the product. This is what we call the process variability. Okay, the differences that occurred during the process. Then source of inspection. Okay, the best inspection is no inspection at all. Okay, doing the job properly at the source, because the inspection is basically is considered as non-value added activities. Okay, it's considered as non-value added, means that either you conduct this process or not, the value of the product itself is not changing. Okay, so source control with employee empowerment. Okay, so means that if we empower the employee, they are keen to control the quality, so indirectly the inspection job can be reduced. Then treat the next step in the process as your customer. So this is another way. So means that although we are in the similar production process, but we treat the next process as our customer. So we want to deliver the high quality and good quality part of product to them. Ensure perfect product to your customer. So this is another one. Okay. Then Pokayoke is the concept of a foolproof device or technique designed to pass only acceptable product. Alright, so Pokayoke is basically a concept. Okay, for example, means that Pokayoke is the concept where we want to make sure that the process or the assembly is doing in the right way for the first time. For an example, if we look at our SIM card, okay, SIM card shape here, okay, SIM card, our SIM card is designed based on Pokayoke concept, where it cannot be inserted into the SIM card slot if we put it in wrong way, right? For example, this is the we need to insert in this way, but we putting in this way, we cannot insert that. Or the edge here, or the top end downside is being flipped, so we cannot put in the SIM card slot. That is one example of Pokayoke. Okay, means that we design a device to make sure that the process or assembly is doing in the right way for the first time. Okay. Okay, so number one, develop cause and effect diagram for the causes of possible student late to class. So you can try to construct this one. So the problem is student getting late to the class. Then the causes, we begin with 4M. Okay, method, material, manpower, and machinery. Okay, so for machinery, for example, you can put maybe related with the vehicle. For example, your motorbike is punctured, or currently we are in online learning mode, so machinery may be related with your laptop having problems, something like that. Then in terms of manpower, okay, maybe because of the student, okay, use yourself uh, uh, maybe wake up late, or maybe lecturers coming too early, and so on. Okay, the account receivable department has documented the following defect over a 30 days period. Okay, what technique would you use, and what conclusion can be drawn about the defect in account receivable department? So you are given this data. Okay, then for this one, basically you need to construct a Pareto chart. Okay, you need to construct a Pareto chart. Okay, now we want to construct a Pareto chart. Alright, first of all, we look at the data here. Okay, invoice amount does not agree with the check amount. Right. Okay, let's say I'm using this data. Okay, what you need to do is basically, before you construct the Pareto chart, okay, you need to identify and sort this item, okay, from the highest to the lowest. Okay, let's me rearrange this one. Okay, let's say this is A, B, C, D, E, and F. Okay, so if I reconstruct this one, so the highest will be A, 108, then C, D, 30, then B, 24, C, 18, then F, we have 12, then finally E, 8. Okay, so this is the normal process. We sort from largest to the lowest. So the total numbers here is 200. Okay, the total here is 200. Okay, so from there you need to calculate the percentage. Okay, so this is frequency, this is percentage. So 108 per 200 is 54%. Okay, here is 15, here is 12%, here is 9%, 6%, and 4%. Okay, okay, so the total is 100, but we need to have another column here which is cumulative percentage. Okay, so for the first one, 54, the cumulative is maintained 54, then plus with 15, 69, plus with 12, 81, plus with 9, 90, 96, 100. Okay, so this is the table that you need to establish. Okay, this one is you need to put in tabulated form. Okay, So these are the category. Okay, and then these are the table. So basically in if this problem or this type of problem is appears in your exam, basically this one will give you a certain type of mark between 4 to 5 marks. So please do not leave this table. Okay, next we will construct the Pareto chart. Okay, so I try to draw here. Okay. Okay, so we have three axes basically. On this side is the frequency, on this side is the cumulative percentage, and on this side are the category or the reason here. Okay, so we put the first one. Okay, and you need to use a proper what we call scale here. So if we look at for the frequency, the highest one is 108, so might be the highest scale here might be 110, let's say we put in that way. Okay, okay, I just draw it roughly. Okay, normally if you need to answer this one, you can use a graph paper. And the cumulative percentage, of course, the highest one is 100, so we put 100 here, then 50, okay, then we can plot the details here. So A is 108. Okay, so roughly around here. Okay, this is A. Then D is 30. B is 24. C is 18. F is 12. And E is 8. Sorry, this is E, this one supposed to be F. Okay, then on cumulative side, okay, the A is 54%, so we need to refer to this side of scale or cumulative axis. 54 is somewhere here. Okay, so we try to put a mark at the middle of the frequency graph. Okay, then the second one is 50. We need to refer to cumulative, not the percentage here, cumulative. The second one is 69, so almost 70. Okay, roughly here. Then 81, so 80 is here. Then 90, 96, and finally 100. Okay, and then from there we need to connect this line. Okay, all right. Then from there also we need to find the position of 80%. So now the 80 scale is here, 80% scale is here. So you need to construct a line through this cumulative line. Then we take this one going to below. Okay, so what does it mean? Okay, based on this chart, basically the company or the people who are doing this study need to concentrate on this problem. Okay, problem on this left side means that A, B and D. Okay, because these three problem contributed to 80% of overall problem. Okay, so normally once you already construct this graph, you need to summarize that what problem need to be focused on, okay, to get 80% of problem here. Okay, so this is the first three problem. And for this graph, basically for the marking purpose, okay, you need to make sure that your cumulative percentage is correct, the frequency scale is correct, okay, the label here is correct, you construct the line here, and also you construct this cumulative line. Okay, and the best way is basically to make sure that the maximum of frequency here is roughly the same at the cumulative percentage at 100%. Okay, it's not necessary to be exactly the same, but you can construct that in this way. It means that the maximum frequency here is roughly at the 100% of cumulative percentage. Alright, so what techniques would you use and what conclusion can be drawn about the defect in the account receivability? So based on the techniques is by using Pareto chart. Conclusion is to focus on this problem, second problem and third problem. Okay, alright, so the way how to construct or how to analyze and construct the problem has been explained here. Okay, so that's all for this part. Thank you.